Ladies and gentlemen, we're about to begin. Michael, please go ahead.
Thank you so much, Amanda. Hello, everybody. My name is Michael Steinhardt, and I want to welcome you to today's eSeminar, which is titled Physical versus Virtual Bottlenecks, What You Really Need to Know. And this event is sponsored by Diskeeper. Now, before I introduce our expert speakers, I do want to cover some basic housekeeping items just to help familiarize you with our new and improved console. So first and foremost, this is a fully interactive event. And our console actually incorporates many social networking tools as well. You can tweet or post information to social media sites, including blogging platforms, bookmarking sites, social news sites, and social networking sites, all directly from our console. Just scroll along the bottom of the screen and click on the Share This widget, and we encourage you to do that. Now, you'll also see the Ask a Question feature on your console, and that's for you to send in your questions. We're going to address as many of those as we can during a live Q&A portion at the end of the seminar. If for some reason we can't answer your question live, you'll definitely get a response via email. Now, you can use the green Resources widget both to download the slides from today's presentation in a PDF file and also to access additional downloads. There's going to be white papers and various other resources that will help you improve SAN performance, increase the efficiency of your infrastructure, and so on. And that's a very valuable service that our sponsors are providing for you, so you get some exclusive content that lets you take a deeper dive into some of the solutions we're going to be discussing today. Also, it's not just about you asking us questions. We're going to be asking you questions as well. Throughout the presentation, we're going to be pushing out some poll questions, and we're going to ask you to take a moment and respond with those, and we'll share the results with you as well, so that it helps you see where the audience is and where your peers are at various points, both in the networking and virtualization process and also in the presentation. Now, there are also a couple of other customizable functions that we want you to be aware of. There is a group chat widget, so you can click on that if you want to start or participate in a chat with your other audience members. In addition, every window that you're looking at, from the slide window to the Q&A box, can be enlarged or collapsed. So if you want to change the look and feel of your console, go right ahead. Now, lastly, when the presentation is complete, we're going to be fielding a very short survey. And your feedback is very important to us because it helps us provide consistently high-quality events. So when we push that out, please take a few moments and fill that out as well. Now, without further ado, I want to introduce today's experts. We have with us Damian Giannunzio, who's a field sales and application engineer at Diskeeper. Damian, how are you?
I'm terrific, Michael. Thanks for asking. I also can't go any further without introducing who will be speaking with me, Steve Deming from Microsoft.
Hi there, Damian. Hi there, Michael. Steve Deming with the U.S. Small and Medium Business and Distribution team at Microsoft.
Well, it's great to have you both with us today, and thank you all very much for turning out. I think that it promises to be a very lively, interactive, and insightful presentation today. And just to go over the agenda very quickly, Damian and Steve are going to provide us with an overview. They're going to be discussing the changing storage ecosystem for applications. They're going to help us identify client-side performance bottlenecks, especially in private cloud environments. They're going to show us how we can expand performance awareness all the way down to the client level. And they're also going to discuss the most often overlooked performance issue in a virtual ecosystem. So I think we're going to gain a lot from this, and I would like to not waste any more time and turn it directly over to Damian.
Thank you so much, Michael. We're going to discuss several topics today, all associated with storage performance. We're going to be talking about the fact that modern storage has changed how files are stored, which has affected what occurs to reads and writes at different levels. We'll discuss how performance issues sourced at the client level are affecting the entire I/O transaction with storage. And finally, we'll talk about how you can solve for the client-level issues and recover lost performance. You should take away from the presentation that with the right solution, you can derive maximum performance from your storage infrastructure and, most importantly, your applications. And I think we wanted to ask a question at this point, Michael.
I think you're absolutely right, actually. So the first question that we have for the audience is, based on your experience, where do you see the greatest disk performance bottlenecks? So we want to get a sense of where you think the lags and latency gets introduced, and then we're going to discuss in a little bit more depth what Damian and Steve have seen in their experience. So your choices are SANS, local storage, virtual storage, or desktop storage. And I'd like you to quickly choose the one that you think is the highest, has the highest impact on disk performance. And we'll take a look at the results in just another second. Without giving anything away, Damian, what's your thought on where things are going to go with this poll question?
This is going to, I think, rely a lot on where their infrastructure is, where they've evolved to, where they're sourcing a lot of their data transactions. So it's going to vary. I mean, it might tell us a bit about the audience, in general, and where they are storage-wise as far as what they're using. That's certainly going to be telling regardless, right? But where they've come to as far as moving forward storage-wise.
All right. Well, I think we're ready to take a look at the results then. And you should be seeing them pop up on your screen momentarily. Here we go. So it looks like the winner by about 10% is SANS. Local storage accounts for about 15.2%, virtual storage at 30%, and desktop storage at 14%. So it looks as though local and desktop, at least in terms of the audience perspective, don't necessarily impact disk performance as much as the traffic on the SAN and also in virtual storage systems.
It makes sense to me, and I think Steve would probably concur about this. We're moving further and further away from solutions of that nature, and it's sort of the known evil, and there's a lot of solutions that have already been implemented for that level. I think a lot of people are still trying to grapple with new technologies and dealing with everything that's being introduced with new storage varieties.
Yeah, I think it reflects how the industry has changed and how our use of the technology has changed. We're seeing that as we embrace the newer technologies, we've got the new problems associated with them and need to address them.
Absolutely, and it ties into perfectly what we're going to move into next, and just talking about the connection between having to assure performance and having to deal with, contend with the issues that bar you from getting that maximum performance. So we're going to talk first about the connection between application performance and storage, and the issues being seen with meeting performance expectations. The vision of storage has changed considerably in recent years, and that poll is somewhat of an indicator of that. While storage capacities have increased exponentially and consolidation has facilitated greater data access speeds, we continue to expect more from it.
And of course, on top of that, the adoption of increasingly more sophisticated approaches to storage present these new challenges that I was just talking about. A tremendous amount of the resources are still thrown at trying to figure out and discover the discovery process so that we can start to experience performance deficits.
Yeah, absolutely. When we start to see those deficits, we start to wonder, okay, why is this occurring? Is it associated with storage variety? Direct attached storage devices, NAS, SAN, all the way through to the cloud, storage variety is immaterial. While there are issues considered generally unique to each, it's relevant to note that at a baseline, performance remains a consistent thorn between all of them. Storage is only doing its job when data is secure and data is fast. And it has to be fast enough to meet and then exceed user expectations.
The more things change, the more they stay the same. And most interestingly, some of the root causes for performance issues haven't changed no matter where we've come from. Namely, disk bottlenecks persist because of the lag in disk evolution to match the memory and processing power.
That's right. That's right.
Sorry, that's all very interesting, but what are the kinds of performance challenges that storage administrators are looking at today?
Michael, I'd say at the outset, I'd call it a lack of full transparency. Reporting is paramount to a great majority of the admins I speak with. The increasing scale of storage means greater distribution of activity across proprietary technology boundaries. Each level of storage introduces unique opportunities for improvement, but this requires full transparency, something I think is lacking in the modern approach. it begs the question, what isn't being seen?
Yeah, and unfortunately, reporting silos still exist within a distributed bare metal reporting from different storage varieties and virtual platforms. While top-level management solutions like Microsoft System Center can provide comprehensive reporting from multiple layers, the rapid expansion has shifted the focus away from critical performance areas like the client.
All right. So reporting is clearly an issue, and we need to be able to get detailed and comprehensive reports across all the layers, as you mentioned. What are some of the other things that we need to solve right now?
Well, from a performance perspective, reporting is so relevant because of the threat that I/O bottlenecks pose. Going back a couple of years, this was not really addressed at new storage levels. A lack of interface between applications and storage meant, for example, no knowledge about whether a file will be read sequentially. Performance evident at the user application level is paramount. Regardless of what's happening below it, this is essential. This is the essential test, I should say, for a high-performing system.
Absolutely right. And, furthermore, I'd say the struggle to keep disk technology consistent with memory and processing remains. While there have been tremendous strides in expanding infrastructure scalability, this hasn't directly addressed the issue. So the emphasis on achieving and maintaining higher service levels is by no means exclusive to the storage layer itself. Performance expectations have been augmented with all of the new higher level offerings, from virtual setups all the way through to cloud.
Right. Now the issues being seen by storage administrators are consistent with those experienced by the virtual administrators. Virtual admins are still responsible for resource balancing across their infrastructure and sniffing out whatever the bottlenecks might be. Due to the consolidation of workload and possibly for resource contention, virtual administrators have to be just as vigilant about eliminating performance barriers as their physical counterparts are.
Yes. So, okay, we've talked about the connection between application performance and storage. We're going to get into further detail now about how data transfer travels from application to storage and how performance degradation travels with it. Here we've got a generic look at how I/O travels from Windows down to a SAN storage model. At the top, you've got what's visible to users and upper-level processes, in this case, a Word doc. A reader-write request originates here, and then it travels down through the I/O subsystems.
And what's important to take away from this image is that actually file storage can be performed and perceived radically differently from layer to layer. The layers themselves express to other levels the relevant details of where a file's pieces can be found, but essentially they take care of their own within their own layer. Within Windows, file pointers are stored locally within the logical volume. Below that, though, the pieces of the file are logically stored in LUN blocks. Below that, the RAID structure may dictate a variety of distribution types, mirroring or striping, for example. So it's all about each layer is focusing on its own stuff.
Yeah, and despite the contrast, the data is all still ultimately nested in physical storage at the bottom, and each layer communicates upwards and downwards, maintaining the thread of a file's location all the way through the logical tiers. Even when file storage can necessitate fragmentation at the block level, it's a different type of fragmentation than file system level fragmentation within Windows, and it may even be intended to optimize placement.
All right, well, here's a question then. How is it relevant, ultimately, how a file is stored at each logical level?
Well, it's all about how it's processed. The I/O path and its various differences from layer to layer ties back into performance. An I/O request within a Windows client starts there at the top level. At this point, the read-or-write from Windows descends through the logical levels beneath and is dealt with differently by each level. Remember, for example, that native fragmentation can occur at the SAN level. Well, this has its own effect on the I/O traffic. Similarly, partition augmentation plays a role, potentially increasing the time taken for individual read or write requests to complete due to the additional time necessary to locate the files.
Right. While many SAN vendors furnish proprietary tools or utilities to resolve and manage these issues at storage levels, partition alignment, etc., these do not address what remains a prime area of concern, the client level. In essence, the amount of I/O generated at the source is constrained exclusively by Windows-level handicaps, no matter how optimized storage layers may be. Whatever I/O that does get generated may be handled totally optimally at lower levels. But why are we accepting that so much additional I/O is being sent in the first place?
Okay, so how do we look out for that?
Well, any analysis of infrastructure performance needs to incorporate the Windows client level. As this is the launch point for I/O requests, admins have to be apprised of bottlenecks occurring at the outset.
And what you'll find is that the level of performance loss tied exclusively to the Windows layer can be profound. It's pretty big. Successful monitoring spells a night and day difference for system activity and I/O efficiency. The benefit becomes clear with I/O efficiency measures implemented once the I/O has been reduced to a minimum, optimal numbers. Performance skyrockets for the entire I/O path.
Right, absolutely. So we're going to go more in-depth now on client-side issues, what's causing them, and how to proactively monitor for them.
So let's start with the Windows Performance Monitor remains an often unsung hero of this information age. The granular visibility of how the operating system is performing is unmatched, and its ease of use continues to improve with each generation of Windows. I've gotten a little insight on what's going on with Windows Server 8, and it continues to be enhanced truly based on customer feedback. The ability to schedule and script monitoring, even remotely, ensures a great deal of autonomy while gathering that data. The Performance Monitor gives us a bird's-eye view of the client level necessary to really see where the performance bottlenecks are occurring.
Okay, so how does it do that? And what are the kinds of things, what are sort of the red flags that we should be looking at?
Okay, so one of the most fundamental metrics to review is split I/Os. The Microsoft TechNet Windows Server Resource Kit describes a split I/O as a division of an I/O request to the disk into multiple requests. So what does that really mean? Additional activity required for reads and writes. Windows understands at the outset of a read or write how many I/Os should be involved in the access, the bare minimum based on the file size. All I/O beyond this are split I/Os, additional activity beyond the optimum.
And another extremely important factor is the disk queue length. This represents the developing latency in the disk's ability to keep up with current read and write requests, instead of having to stow those requests until sufficient resources become available to address the delayed I/Os. The more inefficiently I/O is being handled, the greater the likelihood that a disk queue will develop.
Yep. So this issue remains consistent over SAN data stores. Increased split I/Os and disk queue length in Windows leads to the need for more activity at storage levels. There are other disk metrics that we can look at as well. Disk access times reveal the speed of transfers. Bytes per transfer can display how much data is being efficiently fit into each read or write request.
That's right. Without resolving the disk bottlenecks within the client, an administrator can expect to persistently experience a dramatic reduction in the I/O efficiency within the infrastructure. Performance drops, more energy is consumed due to the extra disk activity, and basically this attacks the overall storage total cost of ownership and impedes maintaining of the internal service level agreements that you've got with your internal customers. It all needs to be observed, addressed, and handled.
Okay, so we need to observe it, we need to address it, we need to handle it, but how do we do that? How do we look out for split I/Os, and what sort of things contribute to their creation and what causes them?
Okay, well, so let's start with their two fundamental causes for split I/Os. Data requests of a size that's too large to fit in a single request, or disk fragmentation. In some limited cases, there are additional split IOs can be prompted by regular system activity, but far more often they're evident of file and free space fragmentation. When files and free space become fragmented within Windows, whether you're on a direct attached storage device or operating at a cloud level, the split IOs start to increase.
Right. So admins today are well equipped to monitor and handle issues with your storage layers. As we've discussed, the awareness needs to expand back to the client level operations and resources.
And therefore, employing Performance Monitor on the client system, the client systems that you suspect of performance deficits will provide you that wealth of data on exactly where the lack of efficiency lies. Watching out for split I/O traffic and increased disk queue lengths will rapidly help you observe and target which clients are suffering at the client level. These two metrics are typically strong evidence of a file system level fragmentation, and the increase in split IOs and disk queue length leads to the file operations taking considerably longer than they should and cascading through the rest of the system.
All right. Well, what are we looking at here with these graphs?
Okay, so Michael, these are graphs of data parsed using Performance Monitor with a workload generated over a prominent contemporary SAN store. This is actually from one of our customers employing a mixture of Diskeeper and V-LOCITY in their infrastructure. Red bars show a test case where fragmentation was permitted to develop unchecked over the course of the workload. Blue bars display the results of the same workload while fragmentation was being actively prevented in real time.
So Damon, what you're telling us here is we've got an apples-to-apples comparison scenario with the exact same workload being generated over a SAN storage system. The only difference being the Windows client-level file fragmentation being different in one example to the other. So we can see the progression from fragmentation to split I/O and disk queue lengths to the time it ultimately takes to complete the operation.
Exactly. Basically, more fragmentation equals more time to complete file operations. And I think it'd be good at this point to just review, Michael. Do we have a review we can throw out there?
It's quiz time.
Absolutely. I think we're ready to push out our next poll question. And again, this is your opportunity to select any three of the choices, but which are the three biggest contributors to poor disk performance? Now that we've had a chance to listen to Damian and Steve hold forth on the subject, you can choose performance monitoring, split I/O caused by oversized requests, split I/O caused by disk fragmentation. There could also be the event viewer or disk queue length. All of those are choices that you can select, but we want you to pick the three biggest ones that will contribute to poor disk performance. I have a feeling having followed the conversation, I have a feeling I have at least an idea of at least two out of the three answers. But I'm not going to speculate because I want everybody in the audience to take a chance to have the opportunity to respond. I will also remind everybody that you can hit the Ask a Question button at any point during the presentation. Several of you already have, to send in your questions for live Q&A at the end of this presentation. If for some reason we can't respond live, I'm hoping that we have so many questions that we just simply can't address all of them. So that's both your motivation to get them in quickly and also your motivation to make them really good questions. But we'll definitely respond via email regardless. And with that, we'll take a look at the results and see just how much attention people have been paying thus far. Here we go. So the vast majority is split I/O caused by disk fragmentation, which would have been my first choice as well. Split I/O caused by oversized requests is close behind, as is disk queue length. And those are all contributors. Event Viewer and Performance Monitor only got a very small amount of responses, and I think that's kind of what you guys were hoping to see. Is that correct?
Well, we look at Performance Monitor as being the tool that we're going to use to monitor these other things. Not hopefully, it's not causing problems on its own. So
that's right.
Excellent.
Okay, so File system level fragmentation leads to I/O inefficiency and disk bottlenecks, an effect we can watch out for using Windows Performance Monitor. These performance hits are felt through all storage layers on physical or virtual machines. So now we'll discuss handling the problem at the source. Let me ask you a question, Steve. In approaching a solution to file fragmentation within Windows, what are some elements of storage we would have to be sensitive to?
Well, first and foremost, it has to avoid additional write activity that can cause unwanted side effects. If snapshots or continuous data protection are in use, that data becomes defragmented or moved and can generate additional storage requirements and the obvious snapshot-related performance lag. If deduplication is being employed, you also need to avoid any dedupe overhead. Deduplication can remove duplicate blocks incorrectly allocated due to defragmentation.
All right, so, no triggering of copy-on-write technologies, no unnecessary write activity. What else?
Well, you have to dramatically minimize or eliminate any thin disk growth. Thin provisioning can occur and is widely implemented at both the virtual disk and the SAN-LUN layer. In both cases, any solution would have to avoid prompting unnecessary expansion.
Makes sense completely. So any optimization can't come at a cost to storage provisioning.
Right. And finally, traditional defragmentation over many SANs could inappropriately place defragmented blocks on higher tiers of storage. This contends with the point and benefit of watermarking, which is getting blocks with actual frequency of user access on higher levels of storage.
Okay, all right. So no triggering of copy-on-write technologies, no unnecessary growth to thin disks or thin LUNs, no artificial increase to the SAN high watermark.
Right.
Okay. What are the kinds of features which would have to be present in order to fully handle issues of I/O inefficiency in a modern infrastructure?
Well, as previously discussed, regular after-the-fact writes from a traditional defragmentation wouldn't work in these types of storage scenarios. There are too many potential negatives. You'd have to take a completely different approach to handling fragmentation, one that proactively prevents it without any additional writes needed. In other words, sort of looking at the crystal ball into the future. A solution would have to be founded on performance gain measures, in part because of the aforementioned copy-on-write technologies, and in part because of the need for improved performance as rapidly as possible. Not all fragmentation is alike, and some of the data can be slower than others files due to that fragmentation. As impossible as it sounds, you couldn't use active resources on the systems. Storage wasn't implemented at a great cost just to host performance-boosting solutions. It has production responsibilities. Any form of optimization needs to come with zero noticeable footprint. That means only ideal resource usage.
Okay. So what about on a virtual platform or in a cloud implementation? Are there any extra requirements here beyond the idle resource usage?
Absolutely. Shared host resources means that the bottlenecks are a distributed problem. Activity on one virtual guest can affect other guests on the same host or storage, something which has to be accounted for.
Okay, well that brings us to Diskeeper 2011 for SANs, which really is the solution. Windows client-level software, Diskeeper completely eliminates disk issues associated with file fragmentation at no cost or penalty to the storage system. It incorporates IntelliWrite technology, which is an advanced file system driver that leverages and improves upon modern Windows file systems' one-size-fits-all file write design in order to write a file in a non-fragmented state on the initial write. It intelligently writes contiguous files to the disk, providing 4 principal benefits above and beyond defragmentation. It prevents the majority of fragmentation from occurring in the first place. It improves file write performance. It's energy friendly. Since no additional activity is required beyond the initial write of the file, there's less storage activity overall. This includes less thin provisioning growth. And best of all, it's 100% compatible with copy-on-write technologies in advanced storage management solutions. For environments and systems where post-write defragmentation can occur, such as during a maintenance window on your SAN system, Diskeeper's efficient mode optimization means exactly that. Total efficiency in handling performance-bogged data. Diskeeper doesn't simply serially defragment any file which is non-contiguous. Advanced analysis indicates which files are most affected, and those are handled intelligently first. The invisitasking feature of Diskeeper ensures that only idle resources are utilized for optimization. Light footprint monitoring from the client verifies the availability of completely idle resources, so Diskeeper never interferes with system processes or user activity.
Okay, so you're going to effectively observe what Windows would traditionally just pass through, and you're going to address those challenges. Now, I see you're reporting some of the numbers from performance gains. They're quite compelling. So how are you achieving this? How does this work?
Okay, so fragmentation prevention provides all of the inherent benefits of defragmentation at no additional write cost. Here you can see the result of workstation tests performed, showing the contrast in I/O activity with and without Diskeeper. The savings in reads and writes means faster file copies and browsing, more consistent video streams. These benefits are just as apparent over SAN-level storage. Less I/O means improved data throughput.
All right, well, that's over at the SAN level, but what about virtual platforms? Because resource awareness in the localized client doesn't necessarily mean that Diskeeper knows when resources are needed somewhere else on the storage system. So how do you account for that? Excellent
point. V-LOCITY adds resource awareness across the virtual platform and then down through the storage layers. Along with IntelliRide, invisitasking, and efficient mode, V-LOCITY incorporates two additional features, vAware and Cognisan, which expand individual agents' knowledge of resource usage across the shared storage infrastructure. The result is complete I/O optimization at no resource cost locally or to other VMs sharing resources. So we've talked about the advantages of Diskeeper and V-LOCITY with regard to handling fragmentation intelligently in the enterprise. What are the realized benefits? Actual client-level user and application performance is improved dramatically. Data speeds are higher. Work is completed more rapidly. Scheduled tasks like backups, antivirus scanning, database operations, they're all more streamlined. The user experience is better, and help desk traffic associated with disk activity disappears. The less that underlying storage is having to do, the less energy is being consumed. Energy costs are down. Reduced I/O means more disk idle time on individual desktops all the way to virtual server farms. Not to mention the fact that all of these benefits are realized with no penalty incurred to copy-on-write features or routines and no thin provision growth. Eliminating unnecessary I/O adds to hardware life. The longevity of storage is tied to its activity, and intelligent handling of file fragmentation can add years to disk life. The busier a system is, the clearer this benefit becomes. So help desk traffic is down associated with storage, energy costs are reduced, hardware life increases. All of this spells reduced total cost of ownership for your infrastructure. It's even clear if you're employing a cloud vendor. Improved performance on those hosted clients gives a greater return on the cloud hosting investment.
This sounds great. So what should we take away from all of this?
Well, administrators should be reviewing their performance monitoring strategies. Are you seeing the whole picture, not just at the lower levels? Application performance is paramount, and eliminating your application's barriers is mission critical. Expanding performance awareness to the client level reveals I/O bottlenecks originating within Windows resulting from file fragmentation. Proactively handling fragmentation with a true solution optimized for virtual environments or direct attached systems will return applications to full capacity. Restoring full client-side performance justifies cost for existing storage hardware and improves the value of the entire infrastructure. And I think we want to basically just recap at this point if you had a question that we can send out.
Yeah, I think we have one last poll question for the audience, and that is, which feature of the Diskeeper Velocity solution intrigues you the most? And which feature do you want to do a little bit more research on? As we mentioned earlier, we do have, in the resources widget on our console, you will be able to download white papers and links that will take you to a deeper dive on all of these. But we're curious, which of these sort of piques your curiosity most? And your choices are IntelliWrite, Efficient Mode, Invisitasking, VAware, or Cognizant. So as I mentioned, take a minute to choose which of these you think is going to have the most impact on your infrastructure, and take advantage of the Q&A tab to send your questions in for Damian and Steve. We've actually racked up quite a nice batch of questions to kick off our Q&A. But before we do, we'll just take a look at the results of this last poll question. Let's just see which feature wins the most intriguing. There we go. It's pretty tight between VAware, IntelliWrite, Cognizant coming in third. Efficient Mode and Invisitasking are a little bit further down, although Invisitasking is still at close to 10% of the audience as well. Damian, how does this match up with the kind of features that customers want to hear more about in your experience?
You know what? It absolutely makes sense. If we consider, the original poll that was run, we have a lot of people in the audience who are currently utilizing SAN or potentially implementing it soon. So they're a lot more interested in actually having IntelliWrite or looking into having a solution that handles issues over an environment that's very sensitive to change, and a solution that handles any issues with performance without any hidden cost. With regard to VAware, it absolutely makes sense. A lot of virtual admins out there who are interested in ensuring that they've got something that's not going to impede the productivity of any other systems on the same host. So this is it's very compelling, but it definitely makes sense given the mock-up of the audience.
All right, great. And with that, I'm ready to start turning things over to our Q&A portion, which, as I mentioned, we're going to answer as many of the questions as we can live. And jumping directly in, this question is a little bit detailed, a little bit granular, but I think, Damian, you can handle it. In a virtual machine environment with 8 or more servers in a clustered server SAN configuration, should we be using a defrag tool on the individual VMs, the hosting server, or both?
Okay, excellent question. So the first thing to note is, these tools are for Windows environments. As long as, and it's regardless of what the logical shell is, as long as you have Windows at any given tier within that structure, at your cluster host or within the individual VMs, what I would recommend is having Velocity agents installed within the individual VMs themselves. And then if you've got bare metal beneath that's hosting them and that's still got Windows on it, you would install Diskeeper. So then you've got optimization occurring at multiple levels, so long as it's within the Windows shell. And
Damian, just to ask, we're not going to see a negative impact on performance overall, having the multiple sets of monitoring and optimization occurring at these different layers?
Absolutely not. You're going to see a bigger impact on as far as performance improvement as a result of that, because we're able to, in that scenario, watch out for and handle more than we would if there were, only Windows above, a non-Windows host, for example.
All right, great. Thank you both for addressing that one. One of the audience members just wanted to make sure that they caught what you were talking about just before we switched over to Q&A. There were 2 products that were mentioned, Diskeeper and question.
Diskeeper and Velocity. So Diskeeper configured for SANs is specifically more for direct attached non-virtual systems, but it's also for distributed storage. And then V-LOCITY is a tool that is absolutely focused on virtual systems. It's an optimizer for virtual machines.
All right. Thanks for clarifying that. Another question that came in earlier on. Where can you pinpoint a split I/O metric?
So that's within Performance Monitor. If you were, in this day and age, if you're manually adding any counters to look for, it's actually one of the logical or physical disk counters. So and it'd be right in there among the other disk counters, which you could be adding if you're creating a new data collector set. If you're looking at the Windows 7 family, or prior to that, if you're just creating a new counter log.
And when I saw that question come in, I immediately opened up a browser session and did a quick search because there are enough steps involved that it's tough to just explain it on the call here. But just do a quick search using search across the internet, and I think you'll find that there's plenty of people who have documented how to find your split I/O metric.
Yeah, absolutely, and above and beyond that as well, we talk to people every day who want assistance with monitoring the performance within their infrastructure. So we do walkthroughs of that nature, and that's something that we can also walk through with you if you're interested in walking through that with someone who is very familiar with the subject.
Great. So here's another question that came in, and this is talking specifically about the need for client-level monitoring. Now, your presentation asserts that Diskeeper still needs to run on the client, even though the main data stores are located on file servers or virtual servers on top of the SAN. And this, at this point, the audience member wants to confirm that that's what you're trying to get at.
Really, the point here is the impact can be felt across that transaction at both ends, because there's fragmentation that occurs, and it natively occurs and develops at that client, right? And while there's a data retrieval or data write occurring to this other storage source, the local client is still having to pull data over, and it's still having to do writes locally while it's interacting with that data. You would really want to be optimizing at both ends of that transaction, though certainly they've hit upon the sort of a fulcrum of logic there, which is you will definitely in that scenario see a greater benefit by optimizing where the data is actually being stored.
Okay, so this particular audience member does have Diskeeper installed at the SQL server and the file server levels, but not necessarily on the client yet. And what are they going to be seeing a dramatic improvement or an incremental improvement by moving it down to that level?
By moving it down to that level, it completely depends on how much the performance hit is perceivable at that level now. And it's sort of that was the point of a little bit of what we were discussing earlier on, which is really monitoring for that is what's going to give them that answer. I could, I think as Steve put earlier, I could crystal ball it, but who can say without actually monitoring? That's really what we recommend. We don't want to just push something without it being evident, and it should just be absolutely evident. If you actually have a look at the performance at that level. Use Perfmon and have a look. And you can download a trial. We have full feature trials of the software. I would applaud you if you, independently checked Perfmon for, let's say, a week, at that tier, and then install a trial of Diskeeper, and then use Perfmon for a week. So you can actually do an apples-to-apples comparison within your own infrastructure. How much have we improved performance at that level?
Gotcha. All right. And that seems like a very reasonable and fairly easy to implement test.
Absolutely.
All right. So the next question that's come in is, does this tool work with database files, with DB files?
Yes, completely. So we're a Microsoft Gold certified partner. We've been operating within Windows for a long, long time. And so we don't actually operate within any container file. We won't open up any databases and function within them. But fortunately, a great deal of databases already come with their own proprietary mechanisms for handling internal fragmentation. What we do in order to optimize is just deal with that external container file. So you will still see performance improvements in that scenario. It's just that's how we function. We're outside, we're within Windows, and we just perceive that as another file.
Gotcha. Okay. Next question that's come in. In a virtual environment where the hosts are booting from the SAN and the virtual machines are in a Hyper-V CSV, would you run Diskeeper on the hosts and the VMs, or just the host? And I guess this is a question that both Damian and Steve could jump into.
Sure. Well, I would say we would run Diskeeper at the host level within the Windows server, and then we would run V-LOCITY within the individual virtual machines. And
I'm deferring to Damian on that because he knows the products. He knows their products much better than I would. So, but that makes sense with everything else we've discussed. So that fits right in line.
All right. And sorry.
I think we have. Did you have another question?
Yeah, there's quite a number actually.
Terrific.
Yeah, the audience is definitely responding in a lively fashion. Is this compatible with all applications on a SAN? What about non-Windows applications? What about Unix or Oracle applications? So that's really, we want to find out if this extends beyond the Windows environment.
Sure, understood completely. So currently, we only support Windows operating systems for installation. This is a piece of software that actually installs within Windows. So we don't actually install at or operate at a lower level than within Windows directly.
All right. Another question that's come in, and this is actually in a higher ed setting. But my VM environment is all connected to the SAN. So which do you recommend then, V-LOCITY or Diskeeper?
V-LOCITY, absolutely.
Okay. Yet another question. Does V-LOCITY 3 offer any benefit for virtual machines that are running on solid-state drives on SANs?
Absolutely, with regard to IntelliWrite specifically, because that's actually a very good question. It opens up just a broader topic of SSD storage.
Sure.
We have another product which specifically targets SSDs based on our research, right? Because we don't want to just push a solution that isn't completely optimal for a given environment. But V-LOCITY within a VM over an SSD, it's still going to benefit 100% from IntelliWrite specifically writing files contiguously from the get-go. The reality is, within an SSD, there's some conjecture, about what relative benefit could be perceived from making files contiguous. The reality is it's still perceivable, actually, that there is a performance improvement if files are contiguous within Windows as far as its perception of file locations, as opposed to non-contiguous. But then it comes down to, well, okay, but what level of optimization is acceptable for an SSD, right? Because they are subject to wear. Fortunately, IntelliWrite completely sidesteps the entire issue. Because it's writing files contiguously from the get-go, you're going to see that performance improvement without any question or need for consideration about the special needs of that disk type. So V-LOCITY would still, I would definitely recommend that for virtual machines that are being implemented over solid state.
All right. And I imagine that having SSDs incorporated into the SAN is already going to deliver a tremendous performance boost.
Absolutely.
So we're just adding more benefit on top of that.
Exactly. It's still mission critical because you're still operating within the confines of Windows and how it's storing files, how it's sorting them, and how it's perceiving where they're located.
Got it. All right. Another question, does Velocity work with a virtual machine that has a physical hard drive attached, which is acting as a file server?
Absolutely. It's not. Velocity is not exclusive to shared storage systems. And that what you just described is still a very common implementation. You know, if you've got older boxes that have just been refabricated for a new use, and now they're hosting some VMs, Velocity is still going to deliver a tremendous benefit.
All right, that's great. Another question: How does this interact with linked clones, for example?
Oh, terrific question. So we, when it comes to linked clones or differencing disks, I suppose the Microsoft counterpart, we automatically, Velocity, with the host agent in communication with the actual virtual host, we automatically detect linked clones, and we conform our optimization for them. And that's completely automatic in real time on the fly, doesn't require interaction from the virtual admin. So no negative impact, I would say, in a nutshell.
Great. And here's a question that's actually been addressed to Stephen. Going back to being able to measure fragmentation and the impact it might be having, how do you measure the impact of fragmentation at the physical host, not the guest? Because in a guest you can use perfmon, but what do you use at the host?
Well, if I understand the question correctly, you're just looking for the percentage of fragmentation. You can still use perfmon depending on what kind of host you're using, but we can still pull that information out. Perhaps I'm misunderstanding the question.
Not really. That's the extent of what we got from.
Well, it sounds like, unfortunately, that there's no additional detail. I'm looking at that question myself, and I'm not seeing any additional detail on what the physical host is. But that's really going to rely more, I think, on the vendor. You know, like whoever's furnishing that hardware. And typically they do provide their own tools, their own methodologies for inspecting, granular performance at their level. So you could accrue that information and then actually just essentially perform a contrast with perfmon data. So you could establish the comparison there and make the connection between the client level performance and the storage level performance by comparing those two data.
All right. Another question that's come in. How does IntelliWrite interact with thin provisioning and deduplication?
Sure, great. So IntelliWrite itself, because it's a file system level driver, and essentially it's improving logic. So there's no additional write occurring. The simple answer is IntelliWrite with regard to any of those. IntelliWrite itself doesn't prompt any growth. It's not doing anything additional beyond shoring up the logic with regard to how files are placed, because it's jumping in at the I/O stack level. I'm sorry, you said thin provisioning, and what was the second technology?
Deduplication.
Sure. So and same with regard to that. In IntelliWrite itself, that feature is just improving how the write is happening in the first place. So there's no poor interactivity in the same way. It's just that Windows is going to be moving that file, whether it's a write or a read, no matter what, because that read or write has been requested. IntelliWrite is simply improving that process.
All right. Appreciate that very much.
Mm-hmm.
So here's the audience member who was asking about the guest versus the host. To clarify, he wants to understand how to measure the impact of fragmentation at the ESX host level.
Okay, fair enough. So we do not furnish Diskeeper, Velocity don't furnish any granular ability to look at those levels because we're operating within Windows exclusively. I would say if you want to look at how performance is being impacted within the ESX host, and this is really from my perspective, because I'm very much interested in client-side performance. But if you have, let's say you've got 10 clients that are installed on that ESX host, and you feel that one client is performing poorly or what have you, and you don't know how much that's being contributed to by the host level itself, well, you could run actual granular monitoring on all of the clients, and you could create a test that basically displayed how any one of those clients was affecting any other. So just juggling monitoring at the client level would actually end up giving you a spectrum view of host level performance. And I know, I understand that sounds somewhat generic, but this is, I'm trying to provide a solution from a client perspective or from an application perspective, because when it comes down to it, the ESX host performance becomes less relevant so long as applications are performing well, right? What's the end result of any form of monitoring? Well, it's user level experience, it's data level experience, for applications.
Absolutely.
Yeah, I think Steve would concur as well.
Yes.
Yeah, and that's definitely the ultimate goal of all of these, is just to make sure the applications are functioning at optimum levels, to make sure that they're not impacting SLAs in a way that's going to cause problems, further upstream at the revenue and business level.
Exactly.
All right. Well, with that, I think that we are definitely reaching the top of the hour, and we've definitely addressed a lot of the major questions that have come in, although here's another one that just wants to clarify, so we still have a minute or two. So if you guys don't mind hanging on for another minute or two, just to clarify, is the goal to install V-LOCITY on VMware hosts and Diskeeper on virtual servers?
So we would recommend V-LOCITY for any virtual installation. So it's as long as, no matter what tier you're looking at, as long as it's a virtual machine, we would recommend installing V-LOCITY. We would recommend installing Diskeeper for any other Windows installation, for non-virtual implementations.
Got it.
Yeah, and that's irregardless to the use case of the system, server, workstation, what have you. That would be the split between those two solutions. Understood.
Mm-hmm. All right. Well, thank you for clarifying that. And I will mention to everybody in the audience that there's still a couple of questions that we haven't been able to get to, but as I said, Damian and Steve will definitely respond via email to any of the outstanding questions. And in fact, if you'd like, Damian can be reached at a particular email address. Do you want to give out your email address, Damian?
Yeah. Oh, yeah. No worries. I do have an extremely long last name, so I'm going to spell it out very slowly.
Okay.
But go ahead and email me if you have any questions about what we've talked about today at DGIANNUNZIO@diskeeper.com. So I know that's a long one, and I apologize.
Well, we can definitely, if you download the slides, you can get the correct spelling of Damian's last name. So there's a little bit of a motivator
there
right
you
there.
Have it.
And that actually does bring us to the wrap up. I want to thank everybody in the audience for participating in such a lively fashion. I think that you definitely got a lot of valuable information today. I know I did. And I want to thank Steve Deming and Damian Giannunzio for their time and their insight today. And also thanks to Diskeeper for sponsoring the event. Now, as I mentioned, if you missed any part of the presentation, you can definitely download the slides to refresh your memory and to pass it along to colleagues. But if you want to actually have somebody listen through, you'll be able to access today's presentation on demand. It'll be available at eSeminarsLive.com. That's www.eSeminarsLive.com. Starting tomorrow, you can view it on demand, and you can also refer any colleagues that you'd like to hear the presentation. As I also mentioned, there's additional downloads that you can get, both white papers and a trial link in the resources widget on your console. And lastly, we would like you to fill out a short survey just to give us your feedback on what you thought of today's presentation. And that's important because it will help us provide high-quality events going forward. So once again, thank you to everybody, including our production team here over at Davis Enterprise for a flawless event, for everybody over at Diskeeper and Microsoft for your help and for your participation. And my name is Michael Steinhardt. I'm going to wish everybody a great day and call the presentation to a close.